helpful when working with materials that are not perfectly flat. Second, the operator can drill blind holes. A blind hole is a hole that does not go all the way through the workpiece. When drilling blind holes in a workpiece using a swivel table, the table can be adjusted to the desired angle or rotation to ensure that the hole is drilled at the correct depth and angle. In this video, we will be discussing about the drilling through and blind holes at an angle using swivel table of drilling machine. Come, let's go into the video.
At the end of this demonstration, you will be able to file surface and right angle and check with tri-square. File to size maintaining accuracy plus or minus 0.02 mm. Align the job for angular drilling. Drill angular through hole. Drill angular blind hole. Tools required. Steel rule 300 mm. A steel rule is a measuring instrument that is used to take accurate measurements of the length, width, and thickness of various components. Scriber. A scriber is a marking tool that is used to make accurate lines on metal surfaces. Punch. A punch is a marking tool that is used to create indentations and other markings on metal surfaces. Ball-peen hammer. A ball-peen hammer is used to shape and form metal components, such as by bending or flattening a piece of metal or by shaping it into a specific form or contour. Hacksaw frame with blade. A hacksaw frame is used along with a blade to cut metals of different sections and is specified by the type and maximum length of the blade that can be fixed. Smooth file. A smooth file is a type of file that has a cutting surface that is much finer than rough or busted files. It is used for fine shaping, smoothing, and finishing work on metal components after initial roughing out work has been done with coarser files. Drill bits required size. Drill bits are a common tool used by fitters for drilling holes into various materials such as metals. Tri-square. A tri-square is a measuring tool used in metalworking to check the accuracy of right angles and to mark straight lines. It is a simple but essential tool for anyone working with metal or other materials. Spirit level. To use a spirit level, the tool is placed on the surface of object being checked and the position of the bubble is observed. If the bubble is centered between the lines on the vial, the surface or object is level or plumb. Machines required. Drilling machine. A bench drilling machine typically consists of a base, a column, a table, and a spindle. The spindle is mounted vertically and is driven by an electric motor which rotates a cutting tool such as a drill bit. Materials required. Mild steel. MS SQ 25x25x80 mm. A swivel table is a device that can be attached to a drilling machine. It allows the user to drill holes at an angle, which can be helpful when trying to reach a specific spot or avoid obstacles. They are also useful for making curved patterns when using a drilling machine that supports swivels. Check the raw material for its size. Mark the required size and cut by hacksawing. File to size 75 x 24 x 24 mm and check with vernier caliper. Mark the given dimension for drilling location as per size by using vernier height gauge. Punch on correct locations of drills. Hold the workpiece in the machine horizontally by keeping the parallel blocks under the workpiece to avoid drill bit tips touching the metal base of machine vise. Check with spirit level. Clamp the machine vise to the drilling machine universal table. Lock and arrest the table rotation in Z-axis. Tilt the drilling machine table at an angle of 15 degrees, lock it and drill hole to the required depth. Align the spindle center and hole location using a locating pin. Center drill the hole till it reaches the formation of a cone. Drill a diameter 8 mm to a depth of 12 mm as shown in drawing using depth bar. Align the spindle center to another hole location. Center drill the hole. Slowly feed the center drill till it reaches the formation of cone. Drill a diameter 10 mm to full depth. Debar and clean the job. Apply thin layer of oil and preserve it for evaluation. Here you can find how does angular drilling of through and blind holes. Angular drilling is a type of drilling operation in which a hole is drilled into a workpiece at an angle to its surface rather than perpendicular to it. This can be used for drilling both through holes which pass completely through the workpiece and blind holes which do not. To drill an angled through hole, the drill bit is positioned at the desired angle relative to the workpiece and is fed through the material until it emerges on the other side. The angle can be set using a variety of tools such as an adjustable angle plate or an angled drill press vise. For blind holes, the process is similar, but the drill is stopped before it penetrates the opposite side of the workpiece. In this case, it is important to carefully measure and mark the drilling depth to avoid drilling too deep.
Let's have a recap of what we have learned today. We have learned to file surface and right angle and check with tri-square. File to size maintaining an accuracy plus or minus 0.02 mm. Align the job for angular drilling. Drill through and blind hole. Drill angular blind holes. Thus, we have learnt about drilling through and blind holes at an angle using swivel table of drilling machine. Hope you have a clear understanding on this. Do this exercise with the help of your instructor. In precision drilling, reaming and tapping, a variety of factors must be considered in order to produce a quality product. The type of material being drilled, the size and shape of the hole, the type of drill bit, the speed of drill bit and the type of lubricant all play a role in the quality of the finished product. In order to produce a precision product, it is important to use the proper drill bit for the material being drilled and to correctly set the speed and lubrication for the drill bit. In this video, we will be discussing about the precision drilling, reaming and tapping and test shop. Come, let's go into the video.
At the end of this demonstration, you will be able to file and finish the job to the overall size, chamfer the corners, drill, ream and tap at specified location, check using plug gauge and thread plug gauge, finish and debar. Tools required. Reamer. A reamer is a cutting tool used to smooth and enlarge a hole that has already been drilled or bored in a workpiece. Tapping tool. A tapping tool is a cutting tool used to create internal threads in a pre-drilled or pre-bored hole. Tapping tools can take many different forms, but the most common type is a hand tap. Center punch. A center punch is a hand tool used to create a small dimple or indentation in a workpiece as a starting point for drilling or other machine operations. A center punch typically consists of a hardened steel rod with a sharp point at one end and a flattened tip at the other. Bench vise. A bench vise is a work-holding device that is mounted on a workbench or table and is used to hold a workpiece firmly in place during machining, cutting, filing, drilling, or other work. Equipment required. Drilling machine. A bench drilling machine typically consists of a base, a column, a table, and a spindle. The spindle is mounted vertically and is driven by an electric motor which rotates a cutting tool such as a drill bit. Hand reamer. A hand reamer is a handheld cutting tool used to smooth and enlarge a previously drilled hole to a precise diameter. It typically consists of a cutting tool, a handle, and a guide and collar that helps to ensure the tool is aligned correctly with the hole being reamed. Tapping. A tap is a handheld tool used to create internal threads in a pre-drilled or pre-bored hole. They typically consist of a tap holder, a handle, and a guide and collar that helps to ensure the tap is aligned correctly with the hole being tapped. Materials required. Workpiece to be drilled, reamed, and tapped. Cutting fluid. Cutting fluid, also known as cutting oil or coolant, is a type of liquid that is used in metalworking and other machining processes to lubricate and cool cutting tools, reduce friction and wear, and remove chips and debris from the workpiece. Precision drilling, reaming, and tapping is a process that is used to create accurate and precise holes in a variety of materials. This process is often used in the manufacturing of parts and components for a variety of industries, including the automotive, aerospace, and medical industries. The first step in the precision drilling, reaming, and tapping process is to drill a pilot hole. This hole will be used to guide the reamer and tap as they are being inserted into the material. The pilot hole should be slightly smaller than the diameter of the reamer and tap. Next, the reamer is inserted into the pilot hole and is used to enlarge the hole to the desired diameter. The reamer will create a smooth and accurate hole. Once the hole has been enlarged, the tap is inserted and used to create threads. The tap will cut threads into the hole, which will allow for a screw or bolt to be inserted. Let's begin with the process. Check the raw materials for its size. File the raw material to its overall dimension 100 into 70 into 10 mm. Mark the dimensional lines for location of holes as per drawing. Punch the witness mark on the object line. Hold the workpiece on a drilling machine table with machine vise. Keep the parallel blocks under the workpiece in machine vise. Fix the center drill in drilling machine spindle through drill chuck and drill center. Drill holes in all the holes punched locations. Set the drilling machine spindle speed according to the diameter of drill and material. Remove the center drill and fix 7.8 mm drill through hole. Set the spindle speed. Fix drills 8.5 mm, 7.0 mm, 9.8 mm, 12 mm drill through holes as per drawing. Fix drill bit and chamfer all the drilled holes on both sides of job 2 mm into 45 degree. Ream 8 mm holes using hand reamer. Check the reamed holes using suitable cylindrical plate plug gauge. Cut M8 and M10 internal threads using hand tap and tap wrench. Clean the burr in the threaded holes. Check the threaded holes using thread plug gauge. File the chamfer portion 5 mm into 45-degree angle using flat file, using busted and smooth grader files. Check the chamfer angle with vernier bevel protractor to an angular accuracy plus or minus 5 minutes. Finish and remove burrs on all surfaces and corners of the job. Apply a little oil and preserve it for evaluation. Now we are going to ream within limits and check reamed holes with cylindrical pins. Determine the drill size for reaming. Use the formula drill diameter is equal to reamed hole size minus undersize plus oversize. Refer to the table for the recommended undersizes in related theory on drill sizes for reaming. Hand reaming. Drill holes for reaming as per the sizes determined. Chamfer the hole ends slightly. This removes burrs and will also help to align the reamer vertically. Fix the work in the bench vise. Use vise clamps to protect the finished surfaces. Ensure that the job is horizontal. Fix the tap wrench on the square end and place the reamer vertically in the hole. Check the alignment with a tri-square. Make corrections if necessary. Turn the wrench in a clockwise direction, applying a slight downward pressure at the same time. Apply pressure evenly at both ends of the wrench. Apply cutting fluid. Turn the wrench steadily and slowly, maintaining the downward pressure. Note: do not turn in the reverse direction. It will scratch the reamed hole. Ream the hole through. Ensure that the taper lead length of the reamer comes out well and clear from the bottom of the work. Do not allow the end of the reamer to strike on the vise. Remove the reamer with an upward pull until the reamer is clear of the hole. Remove the burrs from the bottom of the reamed hole. Clean the hole. Check the accuracy with the cylindrical pins supplied.
Let's have a recap of what we have learned today. We have learned to file and finish the job to the overall size, chamfer all the corners, drill, ream and tap at specified location, check using plug gauge and amp thread plug gauge. Thus, we have learnt about precision drilling, reaming, tapping and test job. Hope you have a clear understanding on this. Do this exercise with the help of your instructor. Dovetailed fitting and radius fitting are two common methods of fitting mating surfaces together in mechanical systems. Dovetail fitting involves creating a trapezoidal shaped groove, a dovetail, in one part and a matching trapezoidal shaped projection in the other part. The two parts are then fitted together with the projection sliding into the groove. Radius fitting, on the other hand, involves creating a curved or rounded surface on one part that matches a similarly curved or rounded surface on the other part. In this video, we will see how to make dovetail fitting and radius fitting. Come, let's go into the video.
At the end of this demonstration, you will be able to file and finish to overall size on part 1 and 2. Mark off dimensions and radius by divider. Remove excess material by chain drilling on part 2. Fix male and female parts and assemble. Finish in debar. Tools required. Steel rule. A steel rule is a measuring instrument that is used to take accurate measurements of the length, width, and thickness of various components. Scriber. A scriber is a marking tool that is used to make accurate lines on metal surfaces. Punch. A punch is a marking tool that is used to create indentations and other markings on metal surfaces. Hammer. A ball-peen hammer is used to shape and form metal components, such as by bending or flattening a piece of metal or by shaping it into a specific form or contour. Divider. Dividers are used for scribing circles, arcs, and for transferring and stepping off distances. Hacksaw frame with blade. A hacksaw frame is used along with a blade to cut metals of different sections and is specified by the type and maximum length of the blade that can be fixed. Files. Bastard, rough, smooth. Files are precision shaping and finishing tools used to create smooth, precise, and accurate surfaces on metal components. Bastard file. A bastard file is a type of file that has a coarse cutting surface, making it ideal for removing large amounts of material quickly from metal components. Rough file. A rough file is a type of file that has a cutting surface that is slightly less coarse than a bastard file, making it ideal for removing smaller amounts of material quickly from metal components. Smooth file. A smooth file is a type of file that has a cutting surface that is much finer than rough or bastard files. It is used for fine shaping, smoothing, and finishing work on metal components after initial roughing out work has been done with coarser files. Half-round file, triangular file. A half-round file is a type of file that has a flat surface on one side and a curved surface on the other. This makes it useful for filing convex or concave surfaces or for creating rounded edges on metal components. Drill bits, diameter 6 mm, diameter 3 mm. Drill bits are a common tool used by fitters for drilling holes into various materials such as metals. Web chisel. These are a type of chisel that is mainly used to separate metals after the completion of chain drilling. Equipment required. Surface plate. Surface plates are used to measure the flatness and precision of other components such as machine parts, tools, and fixtures. They are also used for layout and inspection work where precision and accuracy are critical. Angle plate. An angle plate is a work-holding device used in metalworking and machining that is designed to hold and support work pieces at a precise angle to perform marking function using tools like vernier height gauge. Vernier height gauge. A vernier height gauge, also known as a height gauge or a height caliper, is a precision measuring instrument used in metalworking and mechanical engineering to measure the height of objects, and also it's used to make precise marking on the jobs. Vernier caliper. A vernier caliper is a precision measuring tool used in metalworking and mechanical engineering to measure the internal and external dimensions of objects as well as the depth and step measurements. Bench vise. A bench vise is a work-holding device that is mounted on a workbench or table and is used to hold a workpiece firmly in place during machining, cutting, filing, drilling, or other work. Drill machine. A drill machine is used mainly for drilling holes. They can also be used for enlarging holes with a boring tool or finishing holes with a reamer. Materials required: mild steel flat 75 into 10 into 50 mm, 1 number. 75 into 10 into 40 mm, 1 number. A dovetail fitting is a type of joint that uses angled cuts to secure two pieces together. The angle can be as small as 5 degrees or as large as 60 degrees depending on the project you're working on. Before starting job, there are some preliminary checks to be made. Those are as follows. The first check to be made is raw material check. Check the raw materials for its size using steel rule. Check the raw material size using tri-square. Next, we are going to file all the parts. File the part 1 to its overall sizes, maintaining all given dimensions. File the part 2 to its overall sizes, maintaining all given dimensions. Next, we are going to mark the dimension for making holes in all the parts. Mark the dimension and location of holes as per drawing on part 1 by using vernier height gauge. Mark the dimension and location of holes as per drawing on part 2 by using vernier height gauge. Mark the radius dimension using divider. Now we are going to punch witness marks in all the parts on the marked lines. Punch on the location of holes on part 1 using center punch. Punch on the location of holes on part 2 using center punch. Drill holes. Drill relief holes of diameter 3 mm in part 1. Drill relief holes of diameter 3 mm in part 2. Chain drill in part 2. Chain drilling is a technique used in drilling to create a hole in a material that is larger than the size of the drill bit being used. It involves using multiple drill bits of increasing sizes in a series, drilling a series of overlapping holes in the material until the desired hole size is achieved. Now, let's begin the process on part 1. Part 1. Hacksaw on one side of dovetail of part 1 to remove excess metal is shown. File and check the size with vernier caliper and angle with vernier bevel protractor as shown. Similarly, hacksaw on the other side of round profile, remove excess metal to size and shape as shown. Hacksaw and remove excess metal using bastard, second cut and smooth file. File half round profile using half round file and check the profile with radius gauge. Now, we are going to perform the work on part 2. Hacksaw on one side of dovetail to remove excess metal is shown. Hacksaw and cut off along the chain drilled holes using web chisel and ball peen hammer and remove as shown. File the internal dovetail of part 2 to size and angle and check the size with vernier caliper and angle with vernier bevel protractor. Match part 1 and 2 to fit both dovetail and half round profile. Separate part 1 and 2. File and finish. Deburr all the corners of the job. Apply thin coat of oil and preserve it for evaluation. File and finish to overall size on part 1 and 2. Mark off dimensions and radius by divider. Remove excess material by chain drilling on part 2. Fix male and female parts and assemble. Finish and deburr.
Thus, we have learnt about how to make dovetail fitting and radius fitting. Hope you have a clear understanding on this. Do this exercise with the help of your instructor.
Hello and welcome to the session. Here we will be discussing about drilling and reaming small dia holes to accuracy and correct location for fitting. Let us get into the video now.
Objectives. At the end of this exercise, you shall be able to file flat surfaces and parallel to an accuracy of plus or minus 0.02 mm. Mark off dimensions with a vernier height gauge. Measure dimensions with a vernier caliper. Drill through holes as per drawing. Ream the holes and assemble with dowel pins. Introduction to drilling and reaming. Drilling is the first step of hole making. It is a process of making holes in a solid material. The machine used for drilling is called as drilling machine. It is applied for holes of lower grade accuracy and surface finish. Reaming is another cutting process that uses a rotary cutting tool to create smooth interior walls in an existing hole in a workpiece. The reaming method removes very less material than drill. The main purpose of reaming is to create smooth walls in an existing hole. Points to be noted before drilling any workpiece. Select the correct size drill and put into the chuck and lock it finely. Use high speed for small drill and soft material. Use low speed for large diameter drills and hard materials. Lay out the location and mark it with the center punch. Hold the workpiece firmly in the vise on the machine table and clamp it directly onto the machine table. Once drilling is started, apply the required pressure and continue drilling. While drilling steel, apply cutting oil at the drilling point. Release the pressure slightly when the drill point pierces the low-wet surface of the metal in order to prevent damaging the work and drilling machine. On completion of the drilling, retrace the drill out of the work and put off the power supply. Tools required: steel rule, hacksaw frame with blade, scriber, dot punch, center punch, flat smooth file, vernier caliper, vernier height gauge, dowel pins. Drill bit 5.8 mm, hand reamer 6 mm. Material required: raw material MS flat 60 mm into 60 mm into 10 mm. Marking and locating the hole position. Check the raw material for its size. Observe the given raw material carefully. Check whether there is any formation of rusting, corrosion, and scaling before doing any job. File one flared surface and two adjacent sides at right angles to each other on both pieces. Apply marking media on the surfaces of the job. Marking media is a substance that is applied on the surface of the metal to distinguish the marked line clearly. Marking out is preliminary work of providing guidance lines and centers before doing job. Mark the dimensions and the hole location with a vernier height gauge. Vernier height gauges are used in metrology and metalworking to detect or measure vertical distances. Place the object to be measured on the work table and move the jaw up so that it rests gently on the top surface of the object. Adjust the lock screws to hold the slider in place. Now, read the reading on the display to find out the height of the desired object. Punch the witness mark using dot punch. Dot punch. The angle of the punch is 30 degree or 60 degree. The 60-degree punch is used for marking witness marks and is called as dot punch. Punch the whole location using center punch. The angle of the point is 90 degree in a center punch. This punch is used for locating the centers of the holes. The white punch mark gives a good seating for starting the drill. Remove excess material by sawing the file to size 58 into 58 into 9 mm on both the pieces. Measure the dimensions with a vernier caliper. Clamp both pieces together on the drilling machine vise and keeping parallel blocks under the job. Here, we have to use parallel clamps for holding both jobs. Drilling in part 2. Using a center drill, locate the hole position and drill up to 1 mm depth. Without changing the position of the job, remove the center drill and fix a dia 5.8 mm drill and drill through hole. Similarly, drill the other 3 holes. Remove the job from the drilling machine and ream the holes using hole 6 mm hand reamer by holding in a vise. Fix the 4 dowel pins in reamed holes. Check the squareness of dowel pins and correct location. Apply little oil and preserve it for evaluation. Recap.
So now we can have the recap of what we have discussed in this video. File surface is flat and parallel to an accuracy of plus or minus 0.02 mm. Mark of dimensions with a vernier height gauge. Measure dimensions with a vernier caliper. Drill through holes as per drawing. Ream the holes and assemble with dowel pins. Try this with the help of your instructor. Thank you for watching this video. Hello and welcome to the session. Here we will discuss how to make sliding diamond fitting. Let us get into the video now. A smooth file is used to remove small quantities of material and to give a good finish. A dead smooth file is bring the material to accurate size with a high degree of finish.
Objectives. At the end of the session, you will be able to know file flat surfaces and parallel to an accuracy of plus or minus 0.02 mm. File angular surfaces to an accuracy of plus or minus 15 minutes. Relief drill hole of
dia 3 mm.
Chain drill hole and remove excess metal. File to size and match as per drawing. Finishing and deburr. Types of files. For filing and finishing different profiles, files of different shapes are used. Flat file. These files are used for general purpose work. They are useful for filing and finishing external and internal surfaces. Square file is used for filing square holes, internal square corners, rectangular openings, keyways and splines. Round file A round file is circular in its cross-section. It is used for enlarging the circular holes and filing profiles with fillets. Half-round file. A half-round file is in the shape of a segment of a circle. It is used for filing internal curved surfaces. Knife-edge file. It is used for filing narrow grooves and angles above 100. Triangular file. A triangular file is used for filing corners and angles which are more than 60 degrees.
Hello and welcome to the session. Here we will be discussing about drilling and reaming small dia holes to accuracy and correct location for fitting. Let us get into the video now.
Objectives. At the end of this exercise, you shall be able to file flat surfaces and parallel to an accuracy of plus or minus 0.02